Hello, beautiful people. You're welcome to another exciting lesson on Maths with Ella. Today, we are going to be looking at how to solve simultaneous equations using the matrix method. So, without wasting so much time, let's get straight into it. Now, consider the system of two linear simultaneous equations given as in ax plus by equal s and cx plus dy equal d. Let us call this equation 1 and let us call this equation 2. Now, given this system of linear simultaneous equations 1 and 2, where a, b, c, d, s, and t are known constants and the x, y are unknowns. Now, in order to solve this system using the matrix method, the first thing is to express this system in matrix form, and then we apply our knowledge of inverse of a matrix multiplication to get the values of x and y. So, first step is to write the system in matrix form, and we do that as follows. We have the first matrix will be the matrix of the coefficients of our system. In this system, we said x and y are the unknown, so the coefficients here will be a, b, c, and d. So we have a, b, c, and d. The unknown in this system are x and y being equal to s and t. S and t. So this is the system 1 and 2 written in matrix form. If you multiply this out, you're going to get exactly the system given as in equation 1 and 2. And so we've written our system in matrix form. Let us call this some matrix A. Let's call this matrix U for the unknown, and let's call this B. So in matrix form, our system can be written as AU is equal to B, where A is the matrix of coefficients, U is the matrix of unknowns, and B is the matrix of the right-hand side of our system. And we've written out our matrix in this form. In order to get you the matrix of unknown, we simply pre-multiply both sides by A inverse. So if we pre-multiply both sides by A inverse, we are going to have A inverse B as such. Now, A inverse times A gives us the identity matrix. And here we are left with A inverse B. And the identity matrix times any matrix results in the matrix itself because the identity. So here we are left with U is equal to A inverse B. And this is what we need to know because this is what we are going to be applying in solving our system. So when we have a system of linear simultaneous equations, first thing is to write it out in matrix form. That is, you bring out the first matrix A, that will be the matrix of coefficients, and then the matrix U, that will be the matrix of unknowns. The unknowns in this case are x and y, and then the matrix B will be the matrix of the right hand side of our system. And in order to get U, we simply do A inverse times B. That is, you find the inverse of a matrix of coefficients A, you multiply by B, and you're going to have the values of x and y. Let us illustrate this using an example. Example, use the matrix method to solve the following simultaneous equations. So we have 3x minus 2y equal 5. 4x minus y is equal to 10. Solution, first things first, you bring out the matrix. You write the system in matrix form. That is, you bring out the matrix of coefficients, the matrix of unknown, and the matrix of the right-hand side of the system. And we are going to obtain 3, 2, 4, 3, negative 2, 4, negative 1. This is our matrix of coefficients. And then our unknowns, x and y. X comes first before y. So x and y is equal to 5 and 10. So this is our system. Let's call this system star. This is our system star in matrix form. Now, we can label this A. These are matrix U. And these are matrix B. In order to get U, we said U, we are looking for the matrix of unknowns U, which is the column matrix XY. A inverse B. So this is what we aim at doing. And looking at this, we notice that we need to find the inverse of the matrix A. And from our previous lessons, this should not be a problem. So first, find A inverse. That's the inverse of A. And we know that A inverse is given as 1 over the determinant of A times the adjugate of A. Our determinant of A would be, this is 3, -2, 4, -1. And this will give us -3 minus -8. 3 times -1, -3, minus 2 times 4 times -2, that gives us -8. And so we have 3 minus -8, that gives us 3 plus 8. And that gives us 5 for the determinant of A. Next, we need to find the adjugate of A. Adjugate of A will simply be -1, 3, 2, -4. You interchange the entries of the leading diagonal, and then you change the signs of the alternate diagonal. That's what we've done here. And with this, we obtain A inverse to be 1 over determinant of A, that will be 1 on 5, times the adjugate of A, and that gives us again, you could leave it like this, or you could multiply the matrix by the scalar to obtain -1 on 5, 2 on 5, -4 on 5, and 3 on 5. So that is the matrix A inverse. We are halfway gone with the solution of our problem. Next, we need to do what we call matrix multiplication in order to get U. So again, we write out what we aim at doing so that we can follow up. We are looking for U, and this is A inverse B. We already have A inverse, we have B. We fit it in here. We are going to have our matrix U to be equal to A inverse. I'll take the first form where I'll leave the factor outside. -1, 2, -4, 3, times our matrix B. Our matrix B, we said, was the right-hand side of our system. So that would be 5 and 10. So here, we apply our knowledge of matrix multiplication. And that's going to give us, we keep this factor out first. We multiply. So we do row by column. So we have -5, that's -1 times 5, -5, plus 20. We are done with the first row. We go to the next row, that's -5. -4 times 5, that's -20 plus 30. And that gives us, again, we bring down our factor. -5 plus 20 gives us 15. And -20 plus 30 gives us 10. At this level now, we can take in the factor and simplify. This gives us 15 on 5 is 3. And 10 on 5 is 2. So we have U being equal to 3, 2. And remember, U is a matrix whose entries are X and Y. So we replace U by its matrix entries, we are going to have x, y. These are matrix U from here being equal to, we've obtained U to be equal to this matrix. So we have 3 and 2, and this would imply that our x is equal to 3 and y is equal to 2. Equality of matrices, we equate corresponding entries, and that's it for the solution of our system. The system star we're asked to solve, we had this system of simultaneous equation star, we're asked to solve for x and y, and we've obtained x to be 3 and y to be equal to 2. That's how we proceed to find the solution of a system of linear simultaneous equations using the matrix method. Thank you for being a part of today's lesson. I hope you learned a lot, and if you have any questions, any doubts, any worries, please do leave them in the comment section and we will get back to you. Once more, thank you for watching, and until I come your way again, remain blessed.